Hello, guys. So before we start our first lecture in week number 13, I'm going to just talk about quiz 4. I have got many emails, some of which I even haven't replied to yet because they were very overwhelming. So I will try my best to prioritize. But the common thing that I have seen among the emails when I was skimming them, it was mainly some of you that were concerned about the time, some of you that were concerned that I have similar questions, some of you that were concerned about um, the difficulty of the questions and the assigned time. They do not mismatch. So the basic idea is to just convert the in-class quiz into an online. So that's exactly was the idea, just to do the in-class quiz and convert it into an online, and that's exactly what we did. And we tried to use a randomization techniques for selecting questions, different questions for different students. And that worked well for many, maybe not well for some. But I just want to let you know that things that I can control, I will try my best to control, and things that I'm really ignorant and I don't really know, I'm just trying to learn. So hopefully the following quiz is going to be better because I haven't, or I'm not really prepared to do online course, or I mean to teach a course using the online technology. All right. So hopefully that answers many of your questions. And of course, if you still have questions, I have office hours for every section. So just go to your iCollege and look into the collaboration tab, and try to go there and join the office hours, and I can do my best to answer any of your concerns. So we're gonna have quiz 5 for this week, and I have get many feedbacks about the reducing the number of questions or increasing the time of the quiz, and I will do either one. Okay, so either I will reduce the number of questions, so 20 minutes should be enough for you to get the quiz done, or I will try to do the the other way around, okay, is to increase the time and keep the questions the same. So I will make this decision very soon. All right. So either way, you should face less issues in the following quiz. Hopefully, we're going to get it better. And for quiz 4, I need to meet with the GTA today, see what the feedback is from quiz 4. So if I see that there is consequences of the way we design the quiz, I will be there to help. Okay. So either there are multiple ways that I can do. So just I can do to solve the problem, but all of that depends on the performance. So I cannot judge before I see the data. So let me see the quizzes. And if I see majority are really doing well and a few, then I have to apply a specific strategy. If everyone is really not performing well, then definitely it is the quiz, and then I will try to be there and support you. It's not fair just to judge you based on something that it's trial and error. All right. So I will do my best to support you, and I hope you guys understand the situation. I would rather get my on time playing with the material for at least a semester, and that way I will be like better equipped to provide you with a better experience. But this is what the situation is. But I will try my best. So keep that in mind. That quiz 5 is going to be on Wednesday. It's going to be in the same time, and I got some emails that students are very concerned about. Hey, I've been like trying to install this app and it take me 10 minutes. I wasted 10 minutes from the quiz time. No, that's not how it works. The quiz time starts by the time you say start. When you say start, you start counting the time. So whatever time it took you to install or to plug in your system or to install an app or whatever the thing that prevents or prevented you from starting the quiz in time, that's not going to be part of the quiz time. So the time is going to be mainly started when you click on start the quiz. Is that clear, guys? Okay, so the other concern that when you start the quiz, your quiz is going to be submitted late because you are giving a period of time, 10 to 15 minutes, just in case if someone started late. So you have to prove that, you have to show an error message, or you have to show something that's approved, that proves that the reason is you're late is because of that, okay? And hopefully you're not gonna face this in quiz 5, okay? So as I said, if you have more questions about quiz 4, we have office hours today, okay? So try to join them. Either you are, I updated it, the office hours, and I already updated it, the announcement at iCollege. So just look into your office hours for your either Tuesday, Thursday section, or Monday and Wednesday section. Just look into that, and please join us today during the office hours, just in case if you still have further questions that I did not address, okay, or I haven't yet addressed. The other thing that I would like to talk about as well is the assignment 5 has been released, so it's going to be similar to assignment 4. So please go ahead and try to start working on it right now. Talk to your team, and I know it's going to be better now than assignment 4, because most of, or majority of us now, we are really good in terms of using like Zoom, WebEx, or Meetup, or the Hangout, Googles, or because that's the only way we can meet virtually with our family members, or our friends, or our neighbors. So hopefully you're gonna do the same, and you meet as a team, and you just decide on who is doing what, and how you're gonna get things done based on the given time, okay? And one issue that I really have no way to solve it, which is returning the Raspberry Pis. I have talked to the department chair, and they are talking about a mechanism of returning the Raspberry Pis. They haven't yet got to me, but my guess is that hopefully, if the assumption is correct, hopefully by fall 2020, coronavirus is going to be gone and we're back to school. So that way you must return the Pi, otherwise 25% of your grade in CS 3210 is going to be affected, okay? So please take care of it, use it as much as you want, but just keep it safe, please. All right, guys, again, if I forgot to mention anything, or you have concerns, or you sent an email that I haven't replied, because I'm dealing with 180 students and I have a time frame, so I'll try my best to address as many as I could, and then I have to move on. All right, guys, so please come during the office hours if you still have questions. So what we did, back to the class, we were looking at arithmetic, integer arithmetic, and we looked at shift, how we use shift to do multiplication and division, and we also played with the multiplication, and I think lab 10 covered shift instructions, multiplication instruction, and division. So you've been now, I think if you've done or you submitted lab 10, you should be okay with the division instruction. But if you haven't, then we're gonna cover it today anyway. So today mainly we're gonna cover, let me get, if I can use the pen right here. Okay, that's the pen. So today we're gonna cover this section, okay? We're gonna cover sign integer division. First, you're gonna cover the unsigned division, the unsigned integer division, and then we're gonna do the sign, and then we're gonna learn those instructions, okay? Convert byte to word, and word to byte, and dword to a quad word. We're gonna cover that as well. And then we're gonna look at some examples in there, okay? So this is very important for the IDEV. All right, so let's get started. So let me go here and let's move to the next instruction. And the next slide. So for this instruction, guys, the dev instruction right here, it's very important to understand the basic, the fundamentals, because that's how they design a hardware. So if you look at the division right here, so we have the divisor, that's very important, the amount we need to divide by, and this is the dividend, the thing that we need to divide, right? And definitely, if we want to do this, we're going to have the quotient, which is the result, okay? And then we're going to have the remainder, because that's what happened when we divide maybe 5 by 2, then we're going to get 2.5, right? So this is the quotient, Okay, so this is the quotient, and this is going to be the remainder. Okay, so now it is important to know that. Since we are dealing with integer, guys, so we don't care about the remainder, but you're going to have it there. If you remember when you, in Java, or maybe in your first language, when they taught you how to know whether a number is odd or even, you usually do the mode, right? You're just going to use the mode. Okay, that's not division. You're going to say 5 mode 2. So this mode function, it's going to do the division, but it's not going to look into the quotient. It's going to look into what? The remainder. So if the remainder is not 0, anything but 0, then it's going to tell you that this number is odd, right? But if it's 0, then it's going to tell you that this is an even. So even in integer division, the remainder is going to be kept somewhere, though we don't care, but at least for like integer division, because it's integer, okay? It's not real number. But sometimes we want to know like certain properties or certain questions, or we need to answer specific questions, then we can basically look into the remainder, okay? So, let's now look into the instruction right here. So as I said, that is a single operand is supplied. So when we do the division, remember, and the multiplication, when we say mul for single, right? We're just gonna say maybe EBX. So that we only provide a single operand. The same applies for the div. Okay, so what we provided here is the multiplier. What we're gonna provide here, it is gonna be the divisor. So where is the dividend, right? So the dividend is gonna be assumed like the EBX. When we say mul EBX, we assume that the multiplicand is already on EAX, right? So that's assumed by the instruction. The same for the IDEV right here is going to assume that the dividend is being assigned to a specific register. We're going to look at that. So that's very important for you to know. So the only thing you need to provide is the divisor, okay? And the divisor here has to be either a register or a memory, but no immediate. All right, guys? Okay. So if you look at the example right here, that's your dividend. So if you have your dividend, then you either assign it to AX or DXAX or EDX and EAX. And if you notice, is usually we say that division is the opposite of multiplication, right? And that's exactly reflected right here because everything is upside down. All right, so this is usually used to be where we're going to have the product and the multiplier, right? In the multiplication, right? Now that is the other way around. That's when we're going to have the dividend. Okay, so you're going to have the dividend in the concatenated register. So this is when we're going to do the 8-bit, and this is when we're going to do the 16, and this is when we're going to do the 32-bit division. All right, so if you want to divide 37, then you have to decide to assign it to the AX. All right, and your divisor, you just provide your divisor either as a register or as a memory. Okay, so if you do it for an 8-bit division, then just be careful that your memory must be an 8-bit. But for your register, it doesn't matter. It could be any register. Okay, so once you do that, the IDEV as an instruction right here is going to produce this, right? The quotient and the remainder, right? So it's going to give you this automatically. So the quotient is going to go to where? AL, if we have the dividend in AX. So whatever divisor you have in AX is going to be overwritten. Okay, it's going to be overwritten by the quotient in AL and the remainder in AH. So if you want to know that your division is not an integer division, that means it has a remainder, just read what? Read the AH. But if you don't care, you said, I don't care, I just need the quotient because this is integer division, then just go to AL right away. The same applies when you do 16-bit. So just go to AX if you just need the quotient. All right, guys? Is that kind of clear? Okay, so we're gonna move into like a simple example right here, and let's look at what is it that we're trying to do right here. So we're trying to divide 83 by 2, I'm sorry. Okay, so the quotient should be 41 and the remainder should be what? Should be a 1. That makes sense, right? Right, because we don't have if we say 82 by 2, then we're going to get an even number, right? And then the 1 is the remainder because we removed the 1. So 82, then 83 is going to be 83 from 82, we're going to have the remainder as a 1. So if we assign this to AX, that means we are doing what? Are we doing 16 or 8-bit division? We are using AX, then we are doing what? 8. I know it's a little bit confusing. If we're using this, then this is 16. If we're using EDX concatenated with EAX, we are doing 32. Get used to it. I know it's a little bit confusing. Okay, so when we do this, why we move 2 to BL? Because we cannot divide, right? The dividend cannot be assigned as an immediate. So we move it first to a BL because we are doing an 8-bit division. And then we call the division instruction, right? The div instruction with the what? With just the divisor. Okay, so we give the divisor and a register right here. Okay, so if we do that, then the div instructions is going to do the division, and then the result is going to be 41. Okay, and that's going to be our quotient, right? And then the remainder is going to be a 1, and then we assign it to AH. So this is what we really need to focus on. All right, guys, is that kind of clear? So do you see how the dev instruction works? So what is really important, and I would like you to focus on, is to keep this table in mind. This is very important. You need to understand that I have to provide this, okay? I have to assign this, I'm sorry. And then I have to provide the divisor. If I do this, then I'm ready to call the div, okay? So this is prepare. You need to prepare this, okay? And then once you do this one, this is going to be the result. So that is when the IDEV is going to give the division instruction is going to do. It's going to give you the result in 2 different registers. Okay? All right. So this is exactly how the system works if you look at it from different view right here. Okay? So this is when you assign the 83 to AX, and then you divide it by BL2, and this is going to be your quotient and remainder. All right? Okay, so now if you look at this and we want to do 16-bit. So if you want to do 16-bit, can you guess, guys, what you're going to do? We're going to use 16-bit. Are we going to use AX? No, this is for 16-bit division. Okay, so if we want to do this, then I know what I'm expecting to get, and I know what I'm supposed to provide first or to prepare first. So the first thing that I need to prepare is to provide this value, which is we have right here, to assign it to dx concatenated to ax. We will see how that's going to happen. Okay, and then we're going to look at the 100, which is going to be my divisor, and then I have to make sure that this is an immediate, so I have to assign it to a register. If I do these 2 things right here, then I'm ready to get what? I'm ready to get the result, and I know where to find the result. Okay, so let's look at this. So first, I assigned a 0 to dx. Why I'm doing this? Because this number is this number can fit the AX register. So we don't need the DX. Why we assign 0? Because we don't really know what's on DX. So if you leave it like without assigning a 0, the default value in DX may be going to be 12, and that's going to change the number from 8,003, it's going to be to 12, I don't know, 12 thousands, 12 hundreds, 12 millions, we don't know, right? So it's going to be a completely different number. So we better assign zeros in here. So that way I know that I have 0, 0, 0, 0, and that's going to be my DX. And then I'm going to have 8003, and that's going to be my what? My AX. Okay? So if I know, if I want to do this, I have to move 0 to dx and then move this value where? To ax. So we did this by clearing the dividend, because we have to prepare the dividend with the value, because IDEV is going to consider the value is going to be there. If we do that, then this is exactly now the second step. We have to move this to ax. Now we are ready to call the division instruction. No, not yet, because this is number 1, right? And then now we have to do number 2, which is what? Prepare the divisor. So we have to move the divisor. Since the divisor is an immediate, then we have to move it into a register or a memory. So in our case, we're going to use a register. Okay, so do you see it here? This is your dx, this is your ax, and now I moved the divisor into the cx. Now you are ready to call the dev. Okay, so if you want to call the dev instruction, then you are ready. When you call the div, then you need to provide it with what? With CX, that's your divisor, right? You provide this, and then the div is gonna automatically go to this part, divide it with this, and it's gonna provide you the result. And that's gonna be our number 3. We're gonna get the result. Okay, so if you look at that, this is exactly what happened. Let me see if I can erase this. I'm sorry. Okay, let me see if I can go to the eraser. Okay, and then I can just get rid of that. Okay. Okay. All right, so if we wanna do this, then we're just gonna go back to the pen. And now I know that number 3 right here is gonna be the div instruction is gonna give us what? The result. Okay, so in our case, the result is gonna be here if you see it. So it's gonna be here. That is gonna be the AX, and then that's gonna be the DX, right? So we have the number, and when we divide this number, do we have a remainder right here? So if you look at the DX is gonna be the remainder, right? Do you see it? That is your remainder. So yes, DX is the remainder. So yes, we have a remainder. And how about the quotient, the result, the product? Yes, it's here. So that is the AX. You see it? So this is exactly what this is exactly how it works. Okay, guys, is that clear? All right. So we're going to look in a different example, and that is a different example right here, which is going to be a 32-bit. It's going to be a 32-bit division, right? So this is going to be a big number. Now we know the steps, right? First, we have to prepare the dividend right here, and then we prepare the divisor, and then we're going to call the instruction, right? So this is again 1, 2, and then we have to call the instruction number 3. Just pass the divisor to the instruction, and then the instruction is going to give you the result in EAX. Okay, and if there is a remainder, you're going to find it in EDX. You see it right here. So what we did, since this number is really large to fit on one register, because we have 1, 2, 3, 4, right? So this is okay to handle with EAX, right? So we're gonna handle this number in EAX 00300020, but then we have this, right, number it cannot be fit, so we move it to EDX. So in EDX, we're just gonna say 0008, okay? So just make sure when you put this number together, you remember the concatenation, EDX come first, okay? And then it's gonna be what? EAX, all right? So if you are confused about this, you can do it in your own way. If you say, okay, this number is confusing me, this maybe some of you, they will think, okay, since this is the number, this should go to EDX first, and then this should go to EAX, then try to run the program, and hopefully you will see what I'm talking about. So if you do these two things, then now you have the numbers already assigned, the dividends. So now you need to play with what? You need to play with the divisor. So the divisor is going to be 100. You're going to assign it to ECX. And then number 3, you're just going to call the instruction. So keep these steps in mind. Hopefully it's clear right now. I hope it is clear right now. So this is exactly what the number is. This is the EDX. This is the EAX, because the number starts, remember, this is the low. Okay, and this is the high, right? Remember that? Okay, because if you put these two registers together, this is going to be like this, guys. Okay, let me explain it right here. So you're going to have this size, and then this is going to be EAX, and this is going to be EDX, right? So this is going to be the low register. Remember, AL and AH, this is the same. So you better put the lower value right here. Okay, so this is going to be the first thing. And if you store this in little endians, right? So if you store this in little endian, is going to be what? Okay, so just store this in little endian, okay, and see what happens. Take it then from the memory, little endian, back to the register. And hopefully, if you have any issue, it's going to be resolved right there. Okay, these are more examples. I will let you play with them. Okay, so play with this using Visual Studio, the best way to do it. All right, these are just more examples. All right, so dividing by 0, what happened if you divide by a 0? So you want to avoid that, right? So if you want to learn how to avoid that, This is back to the conditional processing skills that you learn in chapter 7. So what you're going to do right here, you have to move the divisor right to the BL, because we know the steps, right? First, we're going to get the dividend, right? And then we're going to get the divisor, right? And then that's 1, that's 2, and then we're going to get into what? We're going to call the instruction, right? The div instruction. Okay? So these are the steps. So now you are in the second step. You already moved the dividend, right? And then now you want to move the divisor to BL, but you want to compare the divisor with a 0. If it's equal, then no divide by 0. So if it's equal, then you're going to jump over and print a message. Okay, so that way you're going to avoid dividing by 0. If not, then you're just going to go and call the division instruction, which is number 3 in here, and you pass what? The divisor, because you know the divisor is not a 0. Okay, so this is basically the unsigned integer division. All right, so now we're going to learn the signed integer division. So far, so good. So we know the 3 steps: the dividend, the divisor, they're ready. Then you're going to go right away to call the division instruction. One thing to keep in mind, if your data is already stored in a memory, okay, if your data already stored in a memory, then you don't need to really move the divisor into a register, right? So just do the divisor right away. Hopefully that's clear, right? So if you have like a memory A and it is a byte, right? And you have 5 in there, right? And then let's say you have a value BL, okay, sorry, AL has a 10 in there, okay? You see what I'm talking about? So now if you want to use the division, all you need to say move to AL, what, 10, right? And then now you can call divide A right away. So the second step is not going to be there. Do you see it? Because you have a memory. Okay, if this were not to be a memory, if this is like an immediate, if we have an immediate as a 5, just an immediate, right? If this is my immediate, then I will do it in this way. So we have to move to AL 10, and then we have to move to whatever the register, let's say CL5, and then now we're gonna call what? The divisor. The division with the divisor, right? The division instruction. So just gonna do it this way. So it's 3 steps. Okay, it doesn't have to be 3 steps. It could be 2. It depends on the type of operand. If it's a memory, just pass it right away. All right. So now we're gonna handle the signed integer division. Before we do that, we need to understand the basics, and then we're gonna look into the idiv. You see it now, it's different from the div. It's idiv. Here we only have div. You see it? So these are completely 2 different things. Okay? So in order to handle a sign, we need to understand what is integer division and what those instructions are and why we need them. They're very critical, very tricky, and many of my students find it really uncomfortable, especially in the final exams or during the labs, that they forgot to do those steps. Okay? So I'll try my best to help you avoid those type of problems, okay? So the problem right here, when we do the sign integer, we must sign extend before we do the division. What I'm talking about here, what is it? I think it's kind of confusing, because remember, we have AX and we have DX, okay? We have DX concatenated with AX, and we have EDX concatenated with what? EAX, right, guys? So that means I have what in here? I have AH and I have what? AL. These are concatenated, okay? So though this is when we say we do 8-bit, this is when we do 16-bit, this is when we do 32-bit. So before we do anything, we must extend the sign to AH here, or we must extend the sign to DX right here, and the same applies to EAX. So if you have a number, which is -48, and you need to divide this number, you must first extend its sign, because this is your AL, and AH now must all have what? 1, 1, 1, 1, 1, 1, because that is actually the sign. Okay, so we need to extend this one here. Okay, so that's what you see right here. The high byte contains, the high byte contains a copy of the sign, okay, but from the low byte, so it's different now. So this byte right here is mainly for the sign. The same right here, dx is for the sign and edx is for the sign. So what happens if the number is really large or we cannot handle it by EAX? So we're going to look at that case, but this is what we need to do. So the question is how to extend this. Remember back in the days, we used move SX, right? We can use that, right? For the move SX, right? I'm sorry, I forgot the B. Okay, so that's move SX. That works for the addition, right? And subtraction. But for the division, we're going to do something different. But the point that I'm trying to make right here is that you need to understand that we need to extend the sign. That's what really matters. Okay? So if that is the case, then let's move and see here. So how does the sign extension happen? Or how can we accomplish that? Okay? So we're going to go and look at those instructions. This is convert. Convert. The C starts into, starts with the C. That means what? Convert. That means extend the sign. Okay, so if you have a byte, you convert the byte or you extend the byte based on the most significant bit. Okay, so if you look at it here, let me go back. We are extending with the what? We are extended with the most significant bit. If it's 1, then the number is negative, so we extend this with ones. If it's positive, zeros, we extend with zeros. We want to do that. That is the whole idea. So how are we going to do it? We are not going to use this. This is not something that we're going to use, okay? So if you want to do that, then we have to use those instructions. So this is going to convert a byte into a word. So if you have AL and you need to extend the sign of AL to AH, you need to use this, okay? And if you have a word, like in here in AX, and you want to extend the sign to DX, this is the one that's going to help you do the extension. Okay, and then the same applies to the from a double word to a quad word. Okay, so this is very important. That's let me just get you back in those instructions. So is it clear now, guys? Okay, so we need to understand if I'm doing 8-bit, if I'm doing 16-bit, and here if I'm doing what? 32-bit division. So we have to follow those instructions. Okay, extend them before you do anything, period. So that way your dividend is ready to be divided. If you don't do that, you're going to lose points. Okay, so this is tricky. You're going to lose points either in the lab or in the final exam or during quiz 4, 5, or 6. You need to say first, is my dividend ready? Okay, and the div instruction, we don't have a problem. We just move it. Here, it's not easy. Okay, we move it to AX and then we have to extend it. And then now we're going to look into the divisor. If it's in a memory, we call the div instruction and we pass the memory. If it's not, then if it's an immediate, we move it to a register. Then we're going to have the divisor ready. Then we're going to pass the divisor to the iDev instruction, and then the iDev instruction is going to do it. So I will share with you the steps just in a minute. Okay, so let's look at this example right here. So it's sign division. So if we have this number right here, and we are doing 8-bit division, right? So this is what we're going to do, straightforward. So we have to move first. We have to prepare the dividend. Do you see it right here? So we need to really prepare the dividend. But usually in the div instruction, we just move -48 right away to AX. No, we are not going to do it when we do the integers because we care about the sign. So we're just going to move the value to AL first, and then we have to extend because this is AL and AH. So we have to extend the other part. Okay, so if you want to do this, then we have to say convert this byte, which is extend this byte based on the most significant bit. So since this is a negative number, the most significant bit was 1, then we're going to extend the AH byte with what? With 1s. That's my AL. Okay, so do you see the difference now? We are not moving the value right away to the dividend, right? Like the AX, no, we have to move it first to the lower byte, okay? And then we have to extend the high byte with the sign, and that's using this convert byte because we are dealing with 8-bit division. Clearly, guys, is that clear? Okay, so now if we do that one, then we are moving 5 to BL. That's my divisor. That's my dividend, right? and this is now going to be my divisor, right? So this is my divisor, okay? And then now I have divisor and dividend prepared, then I have to go and call what? Call the instruction. Okay, guys, so I just say this is BL, and then it's going to do the division. And if you can look at it here, if we do this division, we have the quotient, right? Right here. It's the same as the div. And then we have a remainder. So the remainder is going to be what? -3, because the whole result is a negative, right? So this is exactly how it works. And the same applies to the 32 and to the 16-bit, okay? So this is if it's 16-bit, then now we have to move to AX, remember? We just moved to AX. All right, and then now we have to convert or extend DX right here with what? With whatever the sign is, okay? Then we move 5 and then we call the div. You see what I'm talking about? So this is very important. This is the same for 32-bit division. All right, guys? Okay, so let me see. This is another interesting example. So you have a number right here. Since we are doing signed integers, we know that this number is negative, and this is what the number is if you convert it. Okay? So if you convert this number, first you have to extend, right? So you are doing what? When you say AX, you are doing a 16-bit. Okay, so you need to extend this sign to where? To DX. So DX should have F, 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 F. So that way we extended it the sign. That means 1, 1, 1, 1, 2, 3, 4, 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3, 4. That's exactly what DX is going to look like, right? This F, 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 F. All right, and then we're just going to move this 4 into the PX, and then now we're going to call the I div, not the div. Okay, so please remember to do this. Okay, and please remember to assign it to the, if you are doing, in this case, 16-bit, here you must say, I'm not going to move it to the entire. I'm not going to 0 DX first and then move the value to AX. That's usually something we already did when we did the div, right? But now when we're using the I div, we have to be careful with that. Okay? So, so this is exactly what the result is going to be. So if you do this result, this is what we care about. This is the DX, which is what is going to be this number, -2. Okay, so if you divide this number with this number, you're going to get this result. Okay, try that in your own calculator. And then you're going to have a remainder, right? So the remainder right here is going to be -1 because this is not. So you're going to have 5, 1, 2, and you divide that with by 100, right? So if you divide that by 100, you're going to get your result right here, and you're going to get your quotient right there. Okay, so this is what the result is. All right, guys, is that kind of clear? Okay. So let me come right here, and with that, we are done with the division. So we know how to do division for unsigned and how to do division for the sign, and now we're just gonna look into the next topic. But before we go there, just to remind you, I hope by now you know how to use shift for at least multiplication and division, quick or fast multiplication and division. And we already looked into the rotation instructions as well. And the multiplication, hopefully you know how to do multiplications, right, for integers, signed or unsigned. This is for the unsigned, and this is for the signed integer. And in the signed integer, we learn 3 ways to do it, either 1 operand, 2 operand, or 3 operands, right? And for the mul, we're just always going to get 1 operand, and we never have the overflow problem. And the same applies right here for the div. So hopefully now you know when you're going to do the I div, you always remember to use CWB, convert a byte to a word, and then convert a word to a D word, or you convert a D word to a quad word. You need to do that before you do anything else. So if you have an AX register, which is using 8-bit division, remember, move the dividend to AL and then extend AH using the convert byte into a word. So that way you're extending the sign to the spot. So in this case, whatever the sign you have in the most significant bit in here is going to be extended it to the AH. Okay? Is that clear, guys? There is the extended addition and subtraction. This is what happened when you try, if you have an 8-bit register and you try to add to 255, which is the maximum. If it's unsigned, you're trying to add a 1. Can you make that happen? We know it's going to be an overflow. Can we handle the overflow and continue instead of killing the process? Yes, we can do this. There is an instruction they call add with carry. And if you want to do it for subtraction, when you're going to go under, when you're going to underflow, then you can say subtract with B, okay, with the carry, okay? So this is very important. So this is the alternative of add, and this is the alternative of sub. Okay, I used to cover them, but we don't have the time to go over them because I want to move into the procedures. But hopefully by now, you know integer arithmetic, the basic integer arithmetic, and the whole idea is that you guys understand that the CBU or whatever you write at the high level language, it really has a long story, and hopefully that's going to make you a better programmer. All right. So for now, I will end the class right here, and I will try to uploaded it, and then I will move to the next topic, which is procedures, and that means we're going to talk mainly about stacks. Okay, so please remember to come during the office hours in case if you have questions. All right, so let me see now. Okay, go here and see you later, guys. Thank you.